Hi TheCodeMans. Welcome back to the channel. These days we can see there is a lot of talk about AI. So today we are going to get familiar with some basics in .NET. I'm going to show you some basic semantic search using AI library available in .NET. So let's go to the code. Okay, what is a semantic search at all? So semantic search is about understanding the meaning of the words rather than just matching keywords. So for example, you know that I have a blog on my website, and let's say I want to implement a search functionality in .NET. The requirement is that I can enter anything in the search field and that search extract the 3 best ranked articles from the mass of the blog posts that match the query I'm searching for. For the simplicity of the example, I will not use the complete article. I will use just the titles of the each blog post I have, and I will put that into list of strings. I have already that prepared. So here you can see I have blog post titles, and there are some titles extracted from my blog post. And now what I want to do, let me show an example. So you have 10k blogs on the website, and in search term I want to type mediator, and I want to get the 3 best results for the semantic search. For example, the first one is mediator pipeline behavior, another one is how to implement CQRS without mediator, and the third one is how to use mediator notifications. By the way, all of those 3 blog posts you can find on my website, and how to implement CQRS without mediator, I recorded that video and you can find it somewhere here. So we have those blog post titles, and now to compare the semantic of those titles, we will need embedded generator to generate embeddings. What is embedding? An embedding is a way of converting text into series of numbers or vector that captures the meaning of that text. So here we will need an embedding generator. Before that, I will need to add a couple of NuGet packages. The first one I'm going to add is Microsoft.Extensions.AI. This is the main package we are going to use. The another package I'm going to add is Microsoft.Extensions.AI Ollama, because we are going to use Ollama as a tool for our models. And I will add another one, which is system numeric tensors. I will explain this one a bit later. So now we can create embedding generator. We have interface for that. Embedding generator. The input will be a string because articles titles are strings. And for embedding, we have embedding with float as a type because the values of the vector will be float numbers. Let's name it embedding generator, and I will use Ollama embedding generator. Ollama embedding generator requires endpoint. Let's say it's a HTTP localhost with a port number 11434, and also we need a model ID, and I will use all mini LM. The first, what is the Ollama? Ollama is a tool designed to simplify the process of running those large language models directly on your computer, on your local host. So you can go to the Ollama website and you can download Ollama. It's pretty straightforward. And for the models, you can search a model that we are going to use, which is all mini LM. You also need to download this model. It's a pretty straightforward. Okay, let's go back to the code. And now we have a generator that we are going to use for generating our vectors for the titles. We have, let's call candidate embeddings, embedding generator, and let's call generate and zip async, and let's pass blog post titles. This method processes all blogs titles at once and converts each one into corresponding embedding. Let me help you to better understand what we have created here. So let's write to the line string join, and let's use one of the embeddings. For example, the first one will be the first title, and let's run application. So you can see various numbers which represents a vector which represents the first title in our blog post titles list. So this vector will be used for comparing semantic between titles. So now we have all the embeddings. Let's create a semantic search. I will create a infinitive loop, and I will take a user input console read line. Also, in order to compare user input queries, semantic, with blog post titles, I also need to create embedding for user input. Now I have input embedding and I have embeddings for all blog post titles. It's time to compare those two and to find the three best. So I will search in candidate embeddings. I will select candidate. I will need the text, which is candidate value, and I will need similarity or score or whatever. And here I'm going to use Cosine similarity calculation, and for that I'm going to use a class from NuGet we added. So tensor primitives Cosine similarity candidate embedding and vector span and user input embedding vector span. I need to fix this one, and in order to get top 3 matches I will just order it by similarity and we'll take top 3 ones. Now we have those 3 matches. So for each match in top matches, let's first print similarity value and let's print the title of the article we need. Now let's run this application to see the result. We have our application up and running and I got a prompt to enter my query. Let's enter mediator like in the example, and you can see that we got those 3 titles. The first one, the similarity is 069, mediator pipeline behavior 61, how to use mediator notification email, and how to implement CQR without mediator. And I can search another one. For example, let's type .NET 9. So we have .NET 9 new link queue methods, health checks in .NET 8, solid principles in .NET. Let's try link queue. We have .NET 9 new link queue method, which is similar as this one. Link queue performance optimization tips and tricks, and exploring C# 13. Okay, this works really well. I want you to explain you how this Cosine similarity function works. So let's say we have a coordinate system in 2 dimensions and we have 2 vectors. For example, this one is x and we have another one, this y is y. So cosine similarity is a measure that looks at the angle between 2 vectors. So if this angle here is 0 degree, that means that those 2 vectors are overlapping. The practical example of this would be to enter a completely the same article name, article title, which means that they're similar. And if the angle is 90 degree, for example, the x was here and we have this angle and this angle is 90 degree, that means that those 2 vectors are opposite vectors and those 2 vectors are dissimilar. In this way, Cosine similarity function help us to find the similarity between vectors and to find the similarity in semantic to help us to create a semantic search. So that was a quick introduction in the basics of AI in .NET with available .NET packages. Tell me in the comments, are you interested in AI in .NET and this type of the content? And I will try to make more content on this. For example, the next video would be something about RAG systems, which is really cool. And that's it for today. If you like this video, please give it a like, subscribe if you want more content like this. See you in the next video. Dream big.